Having seen a 4-bar mechanism where we had 4 links connected with 4 revolute pairs, and then having replaced one of the revolute pairs with a slider, thereby getting a slider crank mechanism, now we are going a step ahead and replacing one more revolute pair with a sliding pair. So we have essentially a mechanism with 4 links connected with 2 revolute pairs and 2 prismatic or sliding pairs. In this particular inversion, we have these sliding pairs adjacent to the fixed link. So we are going to have a fixed link, there will be 2 guides, and in them there will be 2 sliders. And lastly, there will be a link which will be connecting these 2 sliders via 2 pins which fully rotate. So this is the mechanism we are going to look at. Because it has 2 sliders, it is called a double slider, and here is one of its applications. This blue link with a cross slot is our fixed link. In it there are these 2 green sliders, and connecting them is this purple link with 2 hinges at B and C. Midway between the hinges we have taken a point M, and on the extension of BC there is another tracing point T. Let us see their path as we move this mechanism. You will notice T is tracing a perfect ellipse while M is tracing a circle. We will see in a short while how they do it, but because we are getting an ellipse, this mechanism is called an elliptical trammel. Now it might seem rather mysterious how we are getting a perfect circle here and a perfect ellipse from such a simple looking mechanism. But to understand that, let us start with the path traced by this midpoint M of segment CB. The x coordinate of M is given by the horizontal projection of segment CM, and its y coordinate is the vertical projection of this segment MB. So if theta is the angle made by this segment CB with horizontal, then coordinates of M can be written like this. But since M is a midpoint of CB, MC and MB are equal, and we get a parametric equation of circle. Mx and My will be A cos theta, A sin theta. So that is how we trace a circle. For any other point on this purple link, we will get a similar path, only the distances CM and MB were equal here and they will be unequal for any other point. So we will get a parametric equation that says x equal to A cos theta and y equal to B sin theta, equation of an ellipse. Finally, there will be 2 special cases of these ellipses which are infinitely flattened into a double line segment. Those are the paths followed by point C in vertical direction and point B in the horizontal direction. Let us now watch this mechanism in 3D and in action by following this link here. So this is a double slider. This is the cross slot in which these 2 orange colored sliders will be sliding, and the green link is connecting these 2 sliders. The purple flower-like link is not a part of this mechanism. It is just there to make it more interesting. It is called as Geneva wheel, and it gives us intermittent motion. Let us see the animation now.